Lesson 13, 4a, complex numbers in polar form. A complex number is any number that can be written in a plus bi form, where I represents the square root of -1. So I is the square root of -1. Thus, if z is our complex number and it equals 4 plus square root of -9, this square root of -9 I can treat as the square root of 9 times the square root of -1. Well, the square root of 9 we know is 3, and the square root of -1 is I. So this number can be written as a sum of a real value, which is right here, 4, plus an imaginary value, which is right here, 3i. Complex numbers can be graphed using a complex coordinate system. Take this complex number a plus bi. The real part is a, the imaginary part is bi. But as an ordered pair is concerned, we would call this essentially the ordered pair AB, where a, the x coordinate, is the real part, and b, the y coordinate, is the imaginary part. So if we think of a complex plane instead of the Cartesian plane, so instead of an x-axis, we actually have what's called a real axis, and instead of the y-axis, we have an imaginary axis. A plus bi would be graphed where you would come out, since a is the x-coordinate, a units to the right, and since the b is the y-coordinate, you'd come up b units. So out a, up b. A plus bi gets graphed as the ordered pair AB. So if we look at our complex number, 4 plus the square root of -9, or 4 plus 3i, this is going to get graphed essentially as an ordered pair 4, 3i, where you're going to come out 4 on the real, and you're going to go up 3 on the imaginary. Now, here are some definitions of complex numbers in Cartesian form. I already talked about the fact that the square root of -1 is I, the imaginary unit. I squared then would be to take the square root of -1 and square it, essentially losing the radical, giving us -1. So squaring a square root removes the radical sign. I squared is -1. I cubed can be thought of as I squared times I to the first, because 2 plus 1 is 3. While I squared is -1, I to the first is just I, so I get -1 times I, or -I. I to the fourth can be thought of as I squared times I squared, because 2 and 2 add to 4. I squared, notice, is -1, so I get a -1 times a -1, which is a +1. So this pattern then will keep on repeating. You should never have I to a higher power than 1, because I to the fifth is the same as I to the fourth times I to the first, but I to the fourth is 1, I to the first is I, 1 times I is just I to the sixth is I to the fourth times I squared, I to the fourth is 1, I squared is -1, 1 times -1 is 1, is -1 rather. If I open up this next page here, I to the seventh is I to the fourth times I cubed, or 1 times a -I, which is -I. I to the eighth is I to the fourth times I to the fourth, or 1 times 1 is 1. I to the ninth is I to the fourth times I to the fourth times I to the first, 4 plus 4 plus 1 is 9. I to the fourth is 1, so 1 times I, and on and on and on and on. So you will never have I to a power higher than 1, because it's either going to simplify into I -1, -I, or +1. And then you just repeat through it, repeat through it, repeat through it. So never have I to a higher power than 1. Always reduce it to one of these. Now, if z is our complex number a plus bi, That's the general form of a complex number. We always write the real part first, followed by the imaginary. Always real plus imaginary. The real number a is called the real part of z. The number bi is called the imaginary part of z. And a minus bi is the conjugate of a plus bi.